Good day, guys. Welcome back to part 4 of assignment 8 for this video tutorial, which focuses on creating the slope analysis as well as the contour lines for Johannesburg, which is what we did for Gauteng earlier on. So I've actually gone about that process already. So it's basically just repeating what you did for Gauteng, but now for Johannesburg. So I'll just switch off all these layers so it's just not a bit too busy. I'll zoom in a little bit. I'll switch off my Johannesburg. So obviously there's my already clipped digital elevation model for Johannesburg, and I've got my slope already. So basically the slope is also good for basically showing areas that are prone to landslides. Particularly these areas that are highlighted because they've got such a steep slope, therefore they're under the great influence of gravity, particularly under heavy rainfall. Therefore, they're more susceptible to landslides. So, particular areas around your mining belt and a bit to the south. So that's the slope analysis for Johannesburg, and also there's the Johannesburg contours as well. So now, moving on to a bonus feature of this assignment. So basically, the last part of the assignment, which is question 5, is asking you to comment briefly on areas susceptible to flooding, landslides, and earthquakes in Johannesburg. So, how do you actually identify? Firstly, let's start with actually flooding. Which areas are actually susceptible to flooding in Johannesburg? Just basically by looking at the digital elevation model. What you notice if you go back to the beginning of the lesson, the DEM basically shows areas of different elevation. So the lowest point, which is actually black, is 1,281 meters above sea level, while the highest point is 1,890 meters above sea level. So basically, the lowest point in Johannesburg is particularly to the northwestern quadrant of Johannesburg. These particular areas. So, as you know, when rainfall occurs, rain usually descends to the lowest point under the influence of gravity. So, if you notice, even if you go to particular rivers, you notice there's actually banking points on each river. So, what you see here is that we have this black, almost tree branching structure, which is highlighted black, which actually shows the lowest point. Then, on the actual banks of it, you actually have an increase in elevation. So this is actually depicting almost like a river stream. In essence, it's not actually a river, but almost. If a river had to appear, it would almost look similar to this. So obviously, when flooding occurs, rivers obviously burst their flanks, burst their banks. So when flooding is most applicable, where flooding is most likely happen, is particularly around these areas here, where you have these banking points of where you have a low DM compared to on its banks you have actually a high DM. So basically, acts like almost as a river basin in a sense, almost as a bowl in which water gathers, because it's the lowest point on the city of Johannesburg. Obviously, this is not always the case. Obviously, you have miniature pockets that obviously hold water, which are flooding. So, in a sense, that's the commentary in regards to the areas that are most prone to flooding. Around here, where you have these branches around there, and obviously these are your high points. So there's no much flooding here because obviously there's no almost a river basin or to gather water in essence. So also at the same time, working vice versa, these mountainous areas, which are the highest points, particularly around your mining belt in Johannesburg, are also the areas that are actually most prone to what's this now? Landslides, of course, because obviously they're the highest points, they're most prone to gravity and susceptible to gravity elements. Therefore, obviously, most susceptible to landslides in essence. So in regards to the earthquake question, that one is a bit tricky because you have to look at tectonic plates in essence. So that one's always a bit tricky to try and decipher. But um, for a person looking out, particularly let's say if you don't have a strong background, let's say in digital elevation models, it's not easy to actually decipher which areas are prone to flooding, which areas are prone to landslides.